Hi everyone, we have looked at inverses graphically and with tables, and we want to come full circle and wrap it up with how do we find inverses algebraically. So I'm going to walk through one example of what a function would do step by step, and then we'll get to the algebra piece. So this first part again is just kind of background understanding what's happening. We have a function f that takes an input. It adds 2 to that input, it then cubes that, multiplies by 4, subtracts 3, and we finally got our output. What the inverse needs to do is reverse everything that the function does, and it needs to do it in the opposite order. We might not see that opposite order piece in tables or in graphs, but we do see it in equations. So what we need to do is start with our output, which is now our input. So the output of the function is the input of its inverse. We then need to undo subtracting 3. So we will add 3. And then we need to undo multiplication by 4. So we would divide by 4. And then we need to undo cubing. So we would take a cube root. We need to undo adding 2. So we would subtract 2. And then we end up with our output, which should match up with the input of the original function. So the input of the original function should match up with the output of the inverse and vice versa. Okay, so my claim is that I have just written down all the steps that the inverse of this function should do. And truthfully, we have enough of a list here that we can write down a formula. So for function f, we start with an input, that would be like an x, whatever variable you want. We add 2, we take what we've got and we cube it, we multiply that by 4 and subtract 3. So that is my original function. And I am claiming that my inverse function will take an input, it will add 3, it will divide that by 4, we then take the cube root of what we've got, and lastly, we subtract 2. So if these are in fact inverses, what I have claimed before is that when we compose them, we should just get back the identity function x. So let's try it. I think I have enough room here. Let's try f inverse of f of x. And it should work both ways, but we're going to try this way. So f inverse of f of x, we need to plug 4 times x plus 2 cubed minus 3 into our inverse function. Our inverse function will take that, the 4 times x plus 2 cubed minus 3. It will add 3. It will divide by 4, it will take the cube root, and it will subtract 2. So a little bit messy looking, but notice what starts to happen. This set of parentheses that I wrote around what I was plugging in, I don't really need it. I'm not multiplying by anything. I don't have any powers or functions directly applied. So I'm not going to worry about those. What I notice is that I'm subtracting 3 and then adding 3. So those are going to cancel. Let's see, I'm going to sneak down here a little bit. So I'm left with the cube root of 4 times x plus 2 cubed over 4 minus 2. And now I notice that once I get rid of the 3's, I am multiplying by 4 and dividing by 4 back to back here, so I can cancel that out now. And then I'm left with the cube root of x plus 2 cubed minus 2. And now that the 4's are gone, I have a cube and a cube root happening back to back in my order of operations. So now the cube and the cube root will wipe each other out. And I'm left with x plus 2 minus 2, which is in fact the identity function x. So it's true, if I take my function and I undo every single operation that it does in the opposite order, I have my inverse function. I hope that this is maybe ringing some bells for you, maybe, maybe not, but undoing every operation in the opposite order is exactly how we solve equations. They can get messier and we'll have to deal with some other things, but as soon as you can boil an equation down to one variable showing up one time, you just reverse order of operations to solve. So there is a very direct link between solving equations and how we find inverse functions. And it turns out that we can basically force this reverse order of operations thing by solving our original function's equation for its input variable. The one sort of weird thing is that when you do that, if you're using y as your output variable and x as your input variable, you end up with an equation that has x as its output and y as its input. And sometimes that makes sense because that's true. Functions and inverses, the input and output switches. But really, unless we're working on a word problem where our variables are attached to specific meanings, we usually like to have x end up being the input variable again and y the output variable. So to deal with that, typically what we'll do is we will start by swapping our x and y variables, and then we'll solve for the y variable that's now in the input place in our function. So let's go ahead. This sounds really complicated. Let's just go ahead and do it. So I'm going to use this cubic function that I got up above. So it's 4 times x plus 2 cubed. And then we needed to subtract 3. So this was my f of x, and I've already claimed what my f inverse is. But this is how I would really go about finding the inverse if I was given an equation. So I would say, okay, f of x, that's really like my y. You could write f of x, I suppose, but I don't want to write the extra. And in the end, the new function is going to be called f inverse. So step number 1, and this is just so variables end up how we like them, I'll switch my x and my y. I honestly would not be offended at all if you didn't do this step now, but then you'll have to do it at the end. So at some point you're going to switch your x's and y's. Again, the one exception is if it's a word problem and the variables have meaning, we often don't switch our variables because then it gets really confusing. Okay, if I was going to solve for y, I look at this and I say, okay, I'm starting with a single y in this equation, and I have quite a few things happening. If I were to plug in a number, the first thing I would do is add the 2, then I would cube it, then I would multiply by 4, then I would subtract 3. And this maybe is feeling really similar to the list we started with up above. So to solve for y, the first thing I'm going to do is get rid of the 3, and since it was subtracted, I'll do that by adding. So I'll say x plus 3, add 3 to both sides, equals 4 times y plus 2 cubed. The next thing I need to get rid of is the 4, so I'll divide both sides by 4, and I get x plus 3 over 4 equals y plus 2 cubed. Next, I need to get rid of the cube, so I'll take a cube root of both sides. And then the last thing I need to do is get rid of the 2, which I will do by subtracting. And I'm going to rearrange order here. So I have the cube root of x plus 3 over 4 minus 2. And this I can call f inverse of x. So when we get all done, we swap back to our function notation, but we now have the inverse function. And this does match up with what we got the other way by writing out the operations and then reversing their order. But I want to be really clear that writing those out and reversing is, for one, not the most efficient way to do this. It can be prone to some mistakes, but also that as functions get more complicated, it just straight up won't work. It gets too hard to spot exactly what operations are happening in what order when you have your variable showing up multiple times or things get a little messier. Okay, again, often the step after this would be to verify that you really do have an inverse. So we already did this one way. Up above, we tried f inverse of f of x. But if we're going in the usual order, we would find the inverse. And then a potential check would be, let's find, and I'm going to reverse the order just so that you can see it both ways, f of f inverse of x. And again, it should work both ways. Whichever order you compose, this should work. So we are going to take the function f and we're going to plug in this cube root of x plus 3 over 4 minus 2. Function f, which was back here, takes whatever we give it. So in this case, we're giving it the cube root of x plus 3 over 4 minus 2. If in doubt at all, just throw some parentheses around that. It's going to take that, that's going in the x spot right here, and add 2, and then cube everything you've got so far, multiply by 4, and subtract 3. And once again, typically what will happen is things start to cancel out really nicely. So just like last time, the parentheses, the extra set of parentheses I put around my inside function, I don't need them in this case. There's no multiplication, there's no functions applied. So right away I can say the plus 2 minus 2 is going to drop out. I am left with 4 times the cube root of x plus 3 over 4 cubed minus 3. Now that I've gotten rid of the 2's, as I walk through the order of what's happening here, somewhere in the middle, I hit a step where I take the cube root and then I immediately cube what I've got. So whenever those inverse operations hit back to back, those cancel each other out. So that's now gone. I have 4 times x plus 3 over 4 minus 3. Now the multiply by 4 and divide by 4 are happening back to back in order of operations, so those will cancel. I'm left with x plus 3 minus 3, which is just x. So again, I end up with my identity function y equals x. That means that these are in fact inverse functions. So you should be able to algebraically switch your variables and solve to find an inverse formula. You should be able to compose the function and its inverse either way or both ways if asked, and verify that you really do get x. And when you're doing that process, composing the inverses, I want to see, so practice this while you're doing your homework, what order things cancel out in. So it's not okay just to cross everything out and say, whoa, magic, I got x. I need to see step by step that the first thing that canceled out was the plus 2 minus 2, then the cubes, then the 4s, then the 3s. So make sure you're showing work for something like that. Okay, kind of a long one, but that wraps it all up. We now know all the tricks for finding inverses, and basically all of them boil down to switching x and y, right? The input and the output switch. When you're looking at the domain and range of inverse functions, domain and range should also switch. Everything flip-flops. All the inputs and outputs flip-flop. Okay, thanks for watching.